burning question on everyone's minds on a day like this, it's kind of blustery and cold, right?
Yes.
How does salt melt ice? Maddie,
I don't know.
I don't know.
what do we normally do to melt ice?
Heat?
Do we normally add heat? Does salt add heat?
I don't think so.
So let's answer that age-old question. How does salt melt ice? It's experiment time. And the first little experiment is already underway. What do we have here in the pot?
Ice and water.
We have a mixture of ice and water, and there's a temperature probe, a thermocouple inside that. What is the temperature of our ice-water mixture?
0.
And what happens at 0?
Freezes.
Water freezes, but what else is happening at 0?
Ice melting.
Exactly. So you've got both of them going on, right? There's liquid water turning into ice, and ice water turning into a liquid. That's what happens at 0. And that's one of the reasons why it stays at 0. Because there's heat transfer going back and forth, and there's an equilibrium. There's both the same number of molecules turning into ice as there are ice molecules turning back into water. Let's step it up a notch. We're really gonna kick it up here, and that means more ice. Let's do a little experiment here. Take some salt. Just start dumping the salt on. Lots and lots of salt.
Lots and lots?
Lots and lots. We've got a great big mixture of salt and ice there, right? Yeah. And right away, I bet we could probably pour some water out of that. It's starting to melt, right?
Yeah.
0 is the freezing point of water, melting point of ice, but what sort of water?
Pure water?
What have we done to the water here?
Salted it?
Is it pure now?
No.
No, it's not pure anymore. We no longer have pure water, and therefore, perhaps some of its chemistry changes. What do you suppose the temperature of that mixture might be? Is it going to be 0 or
Maybe
something
a
else?
little, maybe a little warmer.
We've got 3 possibilities. We've got, it could be 0, it could be higher than 0. What's the third possibility?
Lower.
It could be lower than 0. Let's take the temperature probe and add it to the salt and ice mixture and see what we get. What's happening to the temperature?
Wow.
Oh, holy smokes, that didn't take very long. What's the temperature?
-6.
Minus 10.
Minus 10. This is where it gets weird. We melt ice by making it cold. It's kind of strange.
Seems a little weird.
Seems a little weird. Important thing to remember though is we start with pure ice, pure water, and now we have impure water. It's the act of adding an impurity that changes the melting point. Let's see if other impurities work as well, okay? So let's try something sweet. Let's go with some sugar. Pour some sugar in there. While you're doing that, we'll bring the temperature probe. Actually, I'm gonna bring it over here, and we'll put that in there. And what's the temperature of our sugar, water, ice mixture?
Below freezing.
It's
Below
below
the freezing point.
what our conventional idea of the freezing point is. It's below the freezing point of pure water.
Pure water.
So even sugar can do it.
We don't sugar our rose.
We don't sugar our roads.
We should.
But we still haven't answered the fundamental question, right? Why does salt melt ice in the first place? When we put the thermocouple into this ice-water mixture, the temperature is 0.
Right.
What does that 0 mean?
That there's melting and freezing going on?
That's right. It's the freezing/melting point of the pure water.
Right.
What does it mean when we put the thermocouple into the salt ice mixture and we see a temperature of -9?
That there's melting and freezing going on at -9?
That's right. We now have a freezing point of -9
Instead of 0.
instead of 0. We've driven the freezing temperature of the water down to -9. If the air temperature or road surface temperature is -5, what happens to the ice that's on the road?
It all melts.
It melts. That's right. We've changed the freezing temperature of water. We've driven it down. We haven't added heat. Instead, we've done the opposite in a sense. We've driven the freezing point down. So if the temperature's above that freezing point, water remains as liquid. But why? When you've got ice and water together, you've got water molecules turning into ice and ice molecules turning into water. When you add impurities like sodium chloride or even sugar, all of a sudden you've got these other molecules in the way. And to put it, gross simplification, these other molecules and ions, they get in the way of the liquid water that wants to freeze. There's less liquid water available to freeze. The melting still happens at the same rate. There's nothing that slows down the melting, but the freezing doesn't happen as fast. So you now have a net melting. You're losing ice, and the only way to get the equilibrium back is for the temperature to go down. When the temperature drops, that slows down the melting, and you eventually get to a point where the melting and the freezing happen at the same rate. We use lots of salt on roads here in Ontario. You go to the prairies, and they don't use salt. Why don't they use salt in the prairies?
It's too cold.
It's too cold. If your temperatures are consistently below -10, there's not much point in adding salt, because all it will do is it'll melt really quickly and then it'll refreeze. You get a nice Zamboni effect. Not good.